Welcome to the Valve Studio. I'm still on my journey to Tonehenge. And tonight I'm back in the lab and I'm answering some questions and I'm going to talk about some performance issues that I've addressed here. And the questions I got came over my YouTube channel, and this is from the last video I made on the Y-axis performance. It's from Ike. It says, hey, he's been following my progress very closely and he has to say I'm doing a fantastic job. Well, thank you very much. I appreciate the comment. And he said he's impressed with how I've set up my whole system so far. Okay, he says he has a WorkBee CNC himself. He bought it from China. Now I got mine from Open Builds here in the United States. And if we look at that, I think it's this page here. I got a WorkBee 1010, which is a 1,000mm machine with lead screws on all the axes. I waited specifically for this to come out. I didn't want a belt drive. I bought one of the original Shapeokos, and I wanted a lead screw machine on my next CNC build. And so he writes in that he started with Gerbil Raspberry Pi approach, and he's been happy with it so far. So that kind of a traditional approach. Now, I'm not telling you anything you don't know, but I'll just go ahead and talk a little bit about what my project differs from this. It's based on Arduino, and he's used. This is not his setup. This is somebody else's. There's an Arduino Uno over here, and then there's some kind of interface board here. Motor drivers back in the back, stepper motor drivers. He's a Raspberry Pi. Looks like he's using one that's really, old. HDMI interface, keyboard, USB hub, monitor, mouse, wires, motors. This is kind of just a big mess. I've done this before, and it works great. It's just for my granddaughter to use this. That's just too many things over here to know. Too many things to go wrong. I want her to go out and flip the thing on, start clamp her workpiece down, start working. And if she wants to go through this whole process of doing CAD CAM, that option's available. But for her, she might just want to cut out squares. I don't know. It's really up to her. Like right there, he's using CNC.js. This is a JavaScript implementation that opens in your browser. This works great. It's just flat out awesome. The first picture I showed you was the universal G-code sender. I've used that as well. Okay, my implementation on the PSoC implements the USB port in the PSoC so that you can do all this as well. You can use G-code sender. You can use the CNC.js. Anything that works over a USB port will work fine with my PSoC implementation. Okay, Open Builds is based on this thing here. This is the WorkBee from Osnest. There's a ton of documentation, and I bought mine from Open Builds primarily because of the community that they've built over the years of all the different projects that people have built, and you can read their build logs. I don't know if you came in from there, but so I post everything over there. And he writes in, he says, two things he'd like to ask me. First thing is, the software for the PSoC, is it stock like in the Git repository you linked in the other videos? Or did you do a lot of changes somewhere? Okay, so this is my fault for not making this clear. I should have had this in every show note. I'm doing everything for this entire project with the hardware, the software, firmware, data sheets. Anything I find for this project, I stick in my Git repository. That's github.com holla2040/Hyatt. This project is, I call it Hyatt. And excuse me, everything is on here, and I based every this PSoC 5. I was talking about it briefly. It's a Cortex M3 that's running at about 70 megahertz, and PSoC devices have a programmable digital block array, and this PSoC 5 has an analog block array. And you can wire that up together in an ad hoc fashion, much like the way you do an FPGA. And then you can map any of those digital I/O or analog I/O to any of the output pins on the physical IC itself, and that makes routing boards a lot easier. I've been aware of these for a little while, and then I read about this port over here. This is from a guy named Bart Dring, and he ported Gerbil over to this PSoC, and he did this about his first project he did almost 2 years ago in March of 2017. And I wrote him about 9 months ago, and I said, hey, is there an update to that? And he said, oh, that code's a mess. Let me work on that for you. So he worked on he updated everything, which is I'm grateful for, and he made this project, Gerbil USB native. He actually took that port, cleaned up the code, made it, available to me, which is great. I mean, I can't thank him enough for doing that. And it uses the PSoC 5 USB port instead of a serial port for communicating with the outside world. Okay, we talked about this before. Okay, so my implementation here, I ended up using. So I'm using this thing here. This is the PSoC 5 LP evaluation board. You can buy it directly from Cypress for $10, and you can get it from other places like DigiKey, Mauser, Arrow, whatever. You can get that for about $15 there. This board's great. It's just like it's a beautiful thing to work with. Super simple. Setup is easy. One limitation is it's the development tools are for Windows only. And fortunately, I bought a used desktop, it was newer one, and I have that dual booted in Windows 10 as well as Ubuntu 16.4. Okay, so for $10, I mean, that's something to evaluate. I mean, if you look at what you can really buy, even on the clone Arduino side, this board is there's really no comparison. When this port came through for Bart, I said, let me just learn more about this PSoC thing. So I started off on this project. And I end up using every available I/O pin for this project, and I've mapped it onto some functionality on this thing. And for those of you who have not done any stuff with PSoC, so I'll briefly go through the design here instead of you having to download this for Creator and PSoC Creator and open it up here. But basically, you have a hardware palette where you wire stuff together in a schematic type form. And so over here, communications, I have two UARTs. See if I can get this to go here. This is a little challenging. Okay, so I have a UART going over to my radio, which is going to be an ESP8266, and I have one running a Z display. And then I have the USB UART up here. This is the one that you can run Gerbil commands across. On the limit switch side, it does hardware debouncing of the limit switches that come in, and you basically set in. This is a programmable logic. It's like a sub block that came from Cypress to do this debouncing, and you run it into a status register. And then the stepper controllers, you have the step here and the direction out, and then you have a control register for setting the stepper enable. This control register here is set up to generate the pulse at the right pulse width for your motor drivers. So it offloads that into hardware, so the microprocessor doesn't have to come around and manage doing the actual toggling of the lines for that. Over here on the input side, I have the traditional three buttons for what a Gerbil supports: cycle, start, reset, and feed hold. And then since it's the PSoC 5 also has an analog subsystem, I have a programmable gain array here, and I'm going to run a probe into that. And then I'm running their DAC, so I have a programmable level control and then I run it into a digital comparator and then that ultimately generates an interrupt, and we'll go over that in future videos. There's the PWM output for spindle to control spindle speed. On the analog side, this board will be able to read in all the power supply current. Feed override is that little potentiometer that I got on the operator interface, and I can also look at the voltage input on that. And it's got a analog multiplexer here, so I select which channel I want to hook into my A to D. Feed override is that there's two buttons that are actually on my feed override knob. And I have the ability to read the IR pulses from that DirecTV remote. And I designed this hardware here so that I just get a single interrupt when a key press is pressed on the remote, and this does all the decoding for the infrared remote. And then finally, on my last page, I got I2C interface for the LCD display. I got an SD card interface, and I have a wheel decoder for the optical encoder that's on my jog wheel. So on a PSoC, what you end up doing is we basically go through a compile process for the hardware design, and it generates an API which generates all these. If you look over here, there's under generated source, it basically generates all the source code that goes into your project, and then when you compile it down, it compiles in. And this is a really nice interface. Everything works great. I haven't had any problems at all. Now, to answer your question, like what kind of modifications did I do? Bart's port of Gerbil to the PSoC is using Gerbil 1.1F, which is fine for what I needed. And anywhere where I added in my modifications for this project to his project, I added the word Hyatt. Okay, I did this on purpose so that if people come in, they can actually find what I modified on top of what he ended up working on. All right. He says that Ike says that he's worked with he's very familiar with microcontrollers and FPGAs as well. However, he's not done any PSoC stuff. Okay. I will tell you a little bit about me. Let me go back over to my other screen here. Okay. I started doing, so this is what I do professionally. I'm an embedded hardware engineer, and my first project, I built a digital fuel injector system for gasoline, for petroleum distribution, and it used a Intel 8188, which was an embedded 8-bit version of the 8086. And I did that in about 1995. So I've been doing embedded stuff for more than 30 years, and I'm really familiar with, well, I don't do any embedded stuff really with Intel, anymore. But I've done a lot of designs. I've probably done at least 100 hardware designs, and I've used microchip PIC parts. I've used AVR parts. I've used lots of different Atmel families, the AT Megas. I've used a lot of the ARM processors, M0, M3, and M4. I helped TI port the Arduino libraries over to one of their M4 processors, and they were introducing that at one of the South by Southwest, and I helped them out with that final port at the final hours. And I've done a lot of stuff with radio work. I've done a lot of different things over the years, and but I've never done anything in depth for the PSoC, and so I wanted to pick a project that was not something way beyond just blinking LED. And from this project here, I got full exposure into what these devices are. They are wonderful to work with. If you haven't done it, pay the $10 and learn how to use one of these devices, because they're great. They're just, everything works. You can be very creative. You can offload a lot of things that you've actually had to do in software. You can offload that into hardware. You can design stuff at the wiring level, which is what I was showing you. You can design stuff in Verilog, which I don't know much about beyond just hello world type of things. But I've done some Verilog, and I do that hardware design. The fact that the PSoC 5 has an analog block in there as well. You can do analog filters. You can do digital filters. You can do, gain stages, multiplexers. If you want to have an A to D converter that has 20 inputs, you run it through a multiplexer. That all works. If you were to look at all the things that Cypress provides as building blocks, that uses the FPGA type matrix on the digital side, there's hundreds of components that you can just slap in and start using right away. They also included that SD file interface, which they licensed through Sager. And I got that working as well. And these are all little sub projects over on the GitHub page. And if you want to go, let me show you that here. The way that I work on all embedded projects is I don't start adding more and more complexity to projects. I figure out everything on a very small level. And so if you look in the source directory over here in GitHub, I have almost every project that I've worked on in the last 10 years. I have this thing called baby steps. And these are little small projects that implement some kind of functionality, and that is it. And they are the simplest implementation to get something to work on the hardware design. So let's take, if we were to take a look at this MCP 23017, this is the I2C IO port expander, and this is based on my board design. And if you were to open this up, this is a PSoC 5 project. You can open it up, and it just exercises the IO expander on my board. Similarly, we have the feed override, which looks at the knob. We have the wheel decoder, which only looks at the wheel. Serial, it just opens the serial ports. The probe is what I was working on to get my little probe to work. So everything I work on over here is done at the very smallest level, and then I take all those code. Once I get all that working, then I just start copying and pasting that functionality blocks into what my final project is. So if you were to look at the source code for the real controller, that's under controller here. And if you come in and look at the hierarchy here, all these source files here that have Hyatt also prefixed onto them are basically copies of those little small projects back into Bart's port of Gerbil to PSoC. All right, I hope I made that simple enough. Okay, on to his next question. Oh, let me say one more thing about the PSoC before you get started. I've had comments on other videos as well. It's like, I've never done this before. I'm interested in learning how to do your project. Can you point me in the right direction? This is not for newbies. Okay, I've done Gerbil stuff before for about 5 different projects. I have multiple decades of experience in hardware design. I've done so many different projects that this thing was actually fun. I haven't been really frustrated at anything on it. You can't just take this and go with it and get it to, you can get it to work, but you need my hardware design. You have to basically duplicate everything I'm doing. If you want to modify that, you have to be pretty well versed in doing in embedded hardware and write stuff down at that level. This is not an Arduino project by any means. This is a straight C project. And so if you're intimidated at all and don't have much experience in that, I wouldn't recommend going down this road. I'd recommend buying a PSoC board for $10 and playing with that, but you got to go a little bit further in your experience level if you're a newbie to actually kind of be in doing this kind of thing. There's a lot of other options to do the same type of thing. You can make that operator interface without going through all this hassle. It'd be hassle for you. I just love doing this stuff. Okay, second thing, how did you get your work bee to position this thing so accurately? Well, thanks. I know I'm getting a lot of comments about that. It's like, holy crap, you're getting 1,000th of a millimeter. Let me show you this. Okay, so I opted to buy these things instead of just a regular NEMA 23 stepper motor. And I got these things. These are integrated step servo motors. So these have the motor driver integrated onto the back of the motor, as well as a optical encoder on the axis. And so it does all that stuff all in one box. Now, these are not these are not cheap motors. This is a quality motor. This is made by a company called Just Motion Control, and this is a Chinese company that only makes. I think they only make these stepper motors. Well, they make stepper motors and servo motors, and I particularly like these over the other integrated solution that has a separate controller box and this giant wiring harness, because everything was integrated in. It's very simple to use. No setup. Turn it on, set your settings, you're good to go. And the ones I got are this, I didn't actually get this 57. No, I did get the 57. IHSS 57-20. And if you're ever on the GitHub page, I do have the datasheet for that over here. If you come over and look in the datasheets directory, there is a datasheet for this thing right here. This JMC IHS 57-XX. So I have that over here if you're interested in looking at that. These are 2 Newton meter motors. These are big monsters. And I've run into some problems with these. The only problem, well, the problem I'm having with these is you can really run these things fast. I'm really fast, and they're really accurate. They have a lot of torque. Because of that, I ended up bending both lead screws in my x-axis and my y-axis. Let's just say we had some accidents over here. My machine is now kind of noisy because my lead screws are bent. But I figured out at some point I'll replace them. But it's good enough for what I need to get done now to get this machine to run. Okay, these things work. I can't say enough about these. I ended up buying these. I got 4 of these for this build, 2 on the Y, X, and a Z, and shipped to me in here in Colorado. I ended up paying probably about $100 a piece for these things. Okay, what's next here? We don't need to go into that. Okay, how did I get it so tight? How did I get the backlash to be on nearly 0? Now he writes in, he says, okay, he gets the part about the servos. All right, sorry about that. About the backlash for different versions of the work bee. So my work bee does not have anti-backlash screws or nuts in there. Mine's using these little blocks, these little Delrin blocks that are machined, and basically Mine are brand new, so I expect the backlash to be low. In fact, when I was threading these on, I couldn't turn the lead screws by hand. They were so tight, so I ended up having to, I 3D printed like a little big knob I could put on the end, and that allowed me to spin it. But I did do something very specific, and I want to talk about how I got these things so tight. So if you look at the axis here, the way I got the whole thing to work pretty well is I first loosened the stepper motor screws. So this whole thing was loose back here. I mean, physically it was loose. And then I loosened these those block attachment screws. And so everything was super loose. And then these retention nuts here, I had those guys really pushed back. And so my lead screw wasn't going to move. And what I ended up doing was if you think about it, let's say that you have this position off a little bit from where that bearing is. You move to this end, you're going to be forcing this whole thing together over here at the end, and that's going to add a lot of stress to your motor. So I ran this axis all the way to the end, and then I tightened up. Actually, what I ended up doing is I moved it all the way to the end, and then I pushed on the gantry in the opposite direction. I pushed on it, and then I tightened up those screws. Okay, so if you know about how those anti-backlash nuts work, they have basically two surfaces that come into contact with both sides of the groove in the lead screw, and so I wanted this one end to be on one end of my threading, the valley. So I pushed the gantry this way, and then I tightened up those screws. Okay, but I did it while that whole gantry was very close to the stepper motor. Then I did the opposite on the other end. So then I ran the thing all the way back down. Actually, while this was all the way nearest the motor, I tightened everything up by pushing on the gantry that way, tightened those screws, and then while it was sitting there, I tightened up the screws to hold the motor in, and so all that stuff was aligned very well on that one end. Then I moved it all the way down to the other end, and remember now, everything's tight except for these two screws. So I moved it all the way back down as far as I could go on this end, and once I got over there, then I tightened up these. But when I tightened up these, I pulled on that block. I just stuck my fingers in there and I pulled on it. That's going to force it on the other side of the V on the lead screw. Then I tightened up those. So now I know that when I go to the ends, I'm not going to add a lot of stress to the stepper motor because I'm now trying to force that in, and it's not fitting very well with that bearing at the end. And then in the middle, it's going to be okay because the lead screw's got a lot of slop on it. It's got a lot of bounce to it, so there's no alignment problems at all in the middle. But once you get to the end, you need to make sure that you have that slider block and the motor kind of aligned up so that you don't force it all together at the end. And then by forcing the blocks apart, when I tightened them, I made it so that they're right on the edge. And you can do that. I'll be able to tune it up. So I think as those Delrin blocks wear, I'll be able to just go through a tuning cycle and just force them out again. And I think that I'll be able to achieve similar type of backlash over the life of these Delrin blocks. Okay. Says no matter how hard he tried, I can't fix it. He doesn't know. All right. Anyway, okay. Well, that answers his questions. Thank you for writing, and I didn't want to reply because, my gosh, I took almost 30 minutes to answer that. I hope that answers your questions. Okay, let's move on to another thing here. No, I'm just going to save the other thing for the next video. All right. Well, let's leave it here. And if you are interested in where I put everything, if you look at the last commit, I did this 4 days ago. And if I make a minor commit, or I basically do a commit the day, at least one, if not more, commits on the day I'm doing development, and I just push them over to GitHub. So if you were to just do a straight clone of this repo at any time, you'll get the latest version. And I really try to keep the master version over on GitHub, and I push to it often. All right. What else can I tell you? Like I said at the beginning of this, I did buy my workbee at Open Builds. After I got this email, I went and I said, well, what is the price difference, right? And so I looked at it and I said, you know what? I can do the same thing that he did. I can go buy it at AliExpress or whatever. But I didn't. Open Builds has been building this community, and if you go over to their website right now, they're running a contest where they say they're celebrating over 1,000 shared builds. There's 1,000 people or more have built stuff with the Open Builds hardware. Their community is huge, and I've had questions in the past, I post them over there. People seem to watch these videos, look at this build, they follow along. What's that worth to me? It's well worth more than the delta would be if I were to cheap it by buying it out of China. I just bought it from these guys. It was well packed, no damage, everything was great. All the documentation's over here. They manage all that stuff. All the CAD files are over here, which allowed me to open that up and bring it into Onshape. This document as well is open. If you get an Onshape account, you can go search for Hyatt. I picked that Hyatt name because it's so odd. If you find Hyatt in there, you'll find all the crap I do. All the designs that I do for this project are all in there. I want to push this as hard as I can because they are really trying hard as a small company to make machines and kits as well, for people like myself to do their own best desktop builds. All right, I'm going to leave it here. Keep trying, and I will keep going. I do have made a little progress, but I'm not going to talk about that here. I'm just going to answer these questions. Okay, well, let's wrap it up here. Thanks for watching. This is the Valve Studio.